All right, we're going to try to find the derivative of this function f of x as shown. And what we use here is the chain rule. Now the chain rule is a rule for the derivative of a composition of functions. Here I can write that y equals u to the fourth power and that u is equal to 5x to the sixth power plus 2x to the third power. And what we see is a composition of those functions where u is replaced by 5x to the sixth plus 2x cubed when I make the composition. All right, now, the way I look at this is I try to block out in my mind this u function, which is the inside function. Okay, let's see what I mean by that. Maybe I'll first highlight in a lighter color. See this inside part? That's what I'm calling u. That's the inside part, the inside function u. It's better probably to call it u than inside, but okay. Now, what I do though is I block that out of my mind and look at the parentheses to the fourth power. That's y equals u to the fourth power. And the first step in the chain rule is I take the derivative of that function raised to the fourth power. So we have this over here. The derivative of u to the fourth is 4 because I bring the 4 to the front using the power rule, and u to the third power. Now, I did not write u. I am going to put in what u is. U is, again, this inside part. So I look at u to the fourth, take the derivative, and then I still put in u, which is 5x to the sixth plus 2x cubed. All right, now that is just taking the derivative of the function u to the fourth. Now, the way the chain rule works is I simply take the derivative of u to the fourth, which is 5u to the third, and multiply it by the derivative of u, of this inside. I multiply by the derivative of the inside. And that derivative, when I use the power rule, is 5 times 6x to the fifth plus 2 times 3x squared. Notice that around this whole piece, which is the derivative of u with respect to x, that whole piece I put parentheses. This on the left is the derivative of y with respect to u. I sort of made it more complicated by showing all that. However, let's keep moving forward. And the question is whether, how to simplify this. So that I think is definitely a valid question, something that can be frustrating, is trying to figure out how to simplify something like this. It's not just figuring out, it's sort of thinking about, well, what can I do here? Is there something more I should do? Should I multiply things through? And I am going to say no, I'm going to leave it like this, at least for now. I suppose there's a question of looking at 30 and 6. Those both have a factor of 6. Should I factor out the factor of 6 and multiply by 4? Could be. But I feel like I'm basically done with this problem. But let me just factor out, because I feel like that's what we might see in a solution in the book. Factor out 6. 30 and 6 have a factor of 6. And let's see if I can get this right without making a mistake. So one of the things I see is that it's often the simplifying afterwards quote, simplifying. Sometimes I wonder. Sometimes the simplifying can take a while. It's interesting, it seems to me in some situations, if I were, say, writing computer code, sometimes I'd like to have it maybe unsimplified so I can come back and see more easily what the process was. But anyway, that's not what we're doing here. Okay, I'm going to highlight this and say that we're done. And that's that. Okay, done with the video. All right, goodbye.